Light and shadow is something which we keep using while sketching. So it's impossible, like in the conditions that we live in on Earth, it's impossible to have a scenario without light and shadow, or like trying to sketch something without light and shadow. You need at least some amount of light, be it artificial or natural, to create a scenario where you're sketching something. On Earth, you have two different kinds of light. Okay, so every other scenario that we have, like if we talk about a primary source of light, there are just two primary sources of light on Earth. Number one, it is the sunlight which is reaching the Earth. The second one is all other kinds of artificial light, okay, which includes light bulbs, CFLs, tube lights, and an artificial fire that someone might have started, or anything like that. So anything which humans have started, which is letting out some light, would be known as artificial lighting. Anything which comes from the sun, okay, basically the sun itself, like, is the natural source of light. Now, there's a big difference between these two different sources of light. So the first cube that you get to see on the top has a shadow which is caused by natural light. This one. The second one has a shadow which is caused by artificial light. And I told you how to identify that. If you look at the sides of the shadow, this one, the cast shadow, there are two kinds of shadows again. Okay. But for now, if you look at the cast shadow, the shadow that is falling on the ground, on the first one, the sides are parallel. On the second one, they are a little divergent, right? So that's the difference between natural light and artificial light. In natural light, the shadow would always be parallel. The edges of the shadow would always be parallel. Okay. On the other hand, in artificial light, if you look at the edges, they would always be divergent. That's the difference between these two different kinds of light. And yep. Now talking about lights again, if you have, like, these are the primary sources of light we are talking about: natural light and artificial light. I'll tell you why and how these two different kinds of lights are different, and why the kind of shadows we get with these lights are different. Okay, but before that, apart from primary source of light, there are secondary sources of lights which are known as reflected lights. Every time the light is falling on the surface or any kind of surface, it's being reflected or bounced off from the surface, and then it is reaching another object, right? So always in every scenario, you'll get two kinds of lights. First would be primary light, which would either be natural or artificial, and the second thing would be secondary light. This is the kind of light which is bouncing off the ground and then reaching the subject. Okay, so always remember, in case of artificial lighting, the light source is closer, the light source is small. In that case, what happens is the kind of rays which would reach the object would be divergent. They would not be parallel, unlike sunlight where the rays were parallel. Okay, so again, the same cube, like now, these are the kinds of rays which are reaching this cube, and hence the kind of shadow you'll get would be divergent. Okay, on the other hand, if you look at natural lighting, the kind of rays which would be reaching the cube would be like this. All the rays would be parallel, and hence the kind of shadow you'll get would always be parallel. The shadow, there are two kinds of shadows now. To understand this, I'll just turn on the light that I have here. Okay, if you look at any kind of object, for instance, if you're looking at this, okay, you can see there are some shadows here, right? You can see there's a line which shows the shadow, then there are some lighter sides here. So there is a lot of transition going on here. Okay, and if you can look at it from my side, I can't do that. I cannot rotate this. If I rotate this again, it would be facing you only. So if you look at it from my side, what happens is there is a darker shadow on this part. Okay, this part is lighter because the light is hitting from this direction. Now there are always two kinds of shadows when you are talking about an object. For instance, if you place it on the ground, there will be some shadow on the object itself because the light is falling on that object, the object is blocking the light rays, and then the part which is opposite to the light, like this part, which my hand is touching right now, would have some darker area. Okay, and the second kind of shadow that we have is when you place it on the ground, there's some shadow on the ground also, right? So this is the part which is being blocked by the, and again you can see some on my face as well right now. So this here, the part which is falling on the ground is known as cast shadow. So every object would have these two different kinds of shadows. If you're talking about any object which is blocking the path of light, it would have these two different kinds of shadows. There would be shadow on the object, there would be cast shadow. Okay, so these are the two kinds of shadows we have. I'll just turn off the light, it's too hot. Yeah. So if I sketch it for you, if you're looking at a cube again, or a cylinder, anything like that, there would be some shadow on the cube. For instance, it would be on this part of the cube, and then there would be some shadow on the ground. Here, in this case, it's what kind of light am I using here? By looking at the shadow, can you just tell me? Is it natural or artificial light?
Artificial light.
Artificial light. So this is what you have here, and then you'll have the shadow here. So these are the two kinds of shadows I was talking about. This is like, if you look at these two sides, these are known as the shadow sides. Okay. So in case of cube, there would be at least one, two, three sides, which would be the shadow side in case of like a light falling on the cube. Whenever you have a light source and you have a cube placed in front of it, there would be at least one side or two sides or three sides which would be receiving shadow. Okay, we call these sides as shadow sides, and the side which is like receiving direct light from the light source would be known as light side. So there can be one or two light sides, or at times three light sides as well, depending on how the cube is placed in front of the light. So here in this case, if this is the light source, the light is falling on these sides, right? And these two sides are not receiving the light. That's the reason why we call these two sides shadow sides. Okay, these two sides would be known as the light sides here in this case. And the shadow sides are responsible for creating the cast shadow. So the cast shadow would always be formed between the shadow sides. Okay, so if we have this, um, this is the light source. Okay, LS. It's a point light source. It's an artificial light source, and then we have an object here, the cube. Is this information enough for me to sketch a shadow? Can someone just tell me? I have a light source and an object. That's what you need, right, to sketch a shadow. Is this information enough? Okay, I'll tell you how this is working. I have a light source. For instance, this is my mobile phone. I just turned on the flashlight. I have a light source and I have an object. This is the condition I've given you right now, an object and a light source, isn't it? Is this information enough for me to know what kind of shadow this object would receive and what kind of shadow it would cast? Where's the ground here? Where is this placed?
I see what you mean.
Yeah. So there's no ground here. So we don't know where this object is, where it is placed, right? And how far this is from this. Okay. The light source right now, look at the light source. You cannot tell by looking at the light source how far it is or how tall it is as compared to the object, right? So you need a base, right? You need a ground on which this cube is placed to get an overall idea where this cube is and how far the light source is from the cube, how tall the light source is as compared to the cube. So there's some information
Mhm.
which is missing, right? And what is
Correct.
that one information? What is that one line which defines the ground for us? Poetically speaking, let's talk poetically. Beaches and oceans.
Horizon.
Horizon. Yes, correct. That was the term I was looking for. Horizon is literally the line which divides the sky and the earth, right? Which is between the sky and the earth, and which marks the ground, that this is where the ground starts, right? So we need a horizontal line here, which is basically the horizon, which would mark the ground for us. We'll then get an idea where this cube is placed, and it has a base on which it is placed. And depending on the horizon, we will get an idea how tall the light source is and how far it is from the object. For instance, if I sketch the horizon here, okay, say this is my horizon. Now you get an idea that the light source is this much tall from the ground. Okay, it's this much taller from the ground, and then the object is this far, right? This is how far the object is as compared to the light source. Okay, so now we know that the light source is far away from the object, and it's the light source is very close to the horizon. So this is the kind of information we need, and I think this much of information is enough for us to sketch the shadow, the cast shadow, and the shadow on the object. So let's go with one case here. I'll sketch the backside of the cube as well for convenience. Let's go with one scenario here where this is the horizon. This is the light source, and then we'll try to sketch the shadow here. The first thing now, what we do is to understand the height of this light source from the ground, we'll just pull a vertical line. Okay, you draw a vertical line from the light source, there's one point which you get on the ground or on the horizon. So this point has a name, and I'll tell you why that kind of name it has. So it is known as SVP, shadow vanishing point. Okay, because I told you with with artificial light, the shadows are divergent. So everything that is divergent on one side would be convergent on the other side, right? If you project it. So this is the point, or this is the point where all the shadow lines converge. Okay, that's the SVP. Okay, if you project it back, for instance, if this is the kind of shadow you have, if you project it back, like these shadow lines, this one and this one, if you project it back, it would meet at the SVP. That's why it is known as the shadow vanishing point. The shadow lines are vanishing on that point. Here, the light would not be falling on 2, 3, and 4. It would only fall on 1. Okay, if you look at it, if I just project the SVP here, if you look at it, this is how the light is being projected from the SVP. So you know that only 1 is receiving direct light. Apart from that, 2, 3, and 4 are not receiving any direct light. So they are the shadow sides. So in this case, there are 3 shadow sides. So now, how do we sketch the light and shadow, and how do we get to know what kind of cast shadow we'll get? So what we'll do here is we'll mark the points corresponding to the shadow sides. So on the top, these are the 4 points which would be corresponding to the shadow sides, right? So let's name them A, capital B, capital C, and capital D. Okay, and we'll then try to mark all of these 4 points on the ground as well. So this is, let's name them small a, small b, small c, and small d. Okay, now we'll try to join the topmost points which are corresponding to the shadow sides with the light source and project those lines. So we'll just join light source to D and then project it, light source to C and then project it, B and then project it, A and then project it. Okay. Now from the SVP, we will join the bottommost points, or the small a, small b, small c, and small d. Someone's mic is on. Yeah. And then we'll project it and we'll try to see where they join with the lines that are coming from the top. Okay. So again, with B, this is the intersection point. With C, this would be the intersection point. With D, this would be the intersection point. Okay. So now this is one of the intersection points. This is second, this is third, this is fourth, right? So now all we need to do is the intersection points that we had, like we joined the light source with the topmost points, we joined the SVP with the bottommost points, and we just tried to see where they intersect. Now the intersection points are the extreme points of the cast shadow. Okay, so now if I just join this part here, this one, this one, this one, and this one, this should give me the shadow or the cast shadow profile of the entire cube. Now, if you turn on any kind of light, be it a flashlight or anything like that, even if you're considering natural light, the natural light is not directly falling on you right now. For instance, if you're looking at my face right now on the camera, the sunlight is not falling directly on my face. Still, you can see my face on the camera, right? How is that happening? This is happening because of reflected light. Now you can see the ventilators, like 2 ventilators behind me, right? So there's some light entering from those ventilators. It's the natural light which is entering. It's being reflected from the roof, from the other sides of the wall, and then reaching my face. So now my face is being illuminated by reflected light. It's not primary light which is illuminating my face. It's reflected light right now. Okay. If sunlight was falling, it would be better illuminated. But right now, reflected light is illuminating. So reflected light is anything which is being reflected from any surface and then reaching an object. So if you look at the shadow side, what we do is what most of you would do. Like people who are not used to sketching light and shadow, what they'll do is if I tell you that these are the shadow sides, you'll just color them black. These are shadow, they should be black, right? This is what you'll do. You'll just color the entire thing black like this. This part is black, this part is black because there's the shadow sides, right? But that's not the case. That's not the case because certain parts of these surfaces as well would be a little lighter, a little darker because of reflected light. Now, if you can
Okay.
look at this, light is coming from the light source. Again, it's radial source, so it's being reflected like this, isn't it? And it's being reflected from these surfaces around the cast shadow area. There are these surfaces around the cast shadow area which are helping the light to reflect and then reach the cube. Okay, so the cube is receiving some secondary illumination from the ground next to the cast shadow area. It cannot receive light, reflected light from this area because this is being blocked by the cube itself. So this is the cast shadow area. It cannot throw back light, but the parts around the cast shadow area are reflecting some light. And if you look at it like that, the light would be reflected on these parts more and these parts more, like this one and this one, right? Because these are the parts next to the cast shadow area through which light can reflect, or these are the surfaces available where the light can reflect. So now we get an idea that these parts, the top left part on the left surface, the top right part of the right surface, these would be receiving some reflected light. So now what is happening because of that is that these parts would be a little lighter as compared to these bottom parts, this one. Okay, so that's what we try to show here. We shade it like this in a manner so that the top left part is a little lighter and as we reach the bottom, this becomes a little darker. Okay, this is caused by reflected light. Okay, although we know this is the shadow side, but still there's some transition because of the reflected light we are receiving here. So yes, reflected light is of much importance when we are trying to sketch something realistically. Okay, on the other side as well, like the top right part would be a little lighter. As we reach the bottom part, this part is a little darker because this part is immediately blocking the light. Right? This part has the cast shadow, so no scope of reflected light here. That's the reason why this part would be a little darker. So this is the kind of shadow we will have with this object here. Now this is the shadow on the object. If we look at the cast shadow here right now, the same concept works with the cast shadow as well. The part which is immediately being blocked, this part here, this would be darker. And then as we move out towards the boundaries of the cast shadow that we have marked here right now, these would be lighter because again, the light is falling on these parts and reaching this part here, right? The reflected light is, or the ambient light is reaching these parts. There are quite a few terms that we use for reflected light. It's either secondary light or reflected light or ambient light as well. At times we call it ambient light because it kind of gives an ambience, right? So yes, the reflected light is reaching these boundaries here, and that's the reason why these boundaries would be a little lighter as compared to the part which is right next to the object. So here we'll try shading this in a manner so that this part here, which is right next to the object, would be the darkest. And as we move out towards the boundaries, this keeps getting lighter. Yep. So this is how this works. Okay. And when we are sketching the cast shadow, again, the lines that we have used is only for our convenience, that they are not actually there. So we can actually erase those lines or make them a little lighter so that it doesn't feel unnatural. So this is what we can do. Say this one here. Again, on this side, we can make this line a little lighter. And again, on this side, we can make this a little lighter. Yeah. So that's how you come up with the shadow of a cube under artificial light. In case of natural light, what happens is there's this object here. In case of natural light, you just have an angle of light and a direction of light, two things. Okay, so if there's an object like this, there would be an angle from which the light would be coming in. Okay, because all the rays are parallel. In this case, the rays are not divergent, so here it's just parallel. And then there would be a directional light. If you project it on ground, you'll get a direction. So you just need to, like, corresponding to all the shadow sides, you just need to intersect this line here and this line here. Okay, and then you'll get the shadow. So I'll show you how it is done. So if this is the cube again, say this is the angle of light. In that case, these two would be, like, 1 and 2 would be the light sides, 3 and 4 would be the shadow sides. So once we have identified the light side and shadow side, what we'll do is we'll just use the same angle here that we can see here. This one, this one, this one. We'll just sketch parallel lines here, okay, from the top points corresponding to the shadow side. Similarly, we'll just project this line on the ground. Okay, this would give us the direction of light, from which direction the light is coming in. And the top point is actually giving us, like, when the lines are projected from the top points, giving us an idea about the angle of the light. So yes, this is the angle and this would be the direction. So here, if you intersect these three, you'll get three intersection points again, and this should give you an idea about the cast shadow. Okay, so this is the kind of cast shadow you'll get here. You're just intersecting the direction of light and the angle of light from the top and bottom points corresponding to the shadow side. So this is the kind of shadow you'll get. Rest, everything remains the same. Okay, this part would be darker here. The part right next to the object would be darker. As you move out, this becomes lighter. Okay, this is how it works. It should be an even blend. This is how this works. And then if you look at the shadow sides here, this one and this one, again, these would be a little darker as you move towards the top left here on this part, and Top right on this part, this would be a little dark, light. So this is how it would work. Always remember the cast shadow is the darkest shadow in an object. Okay, the value. If you look at the value, the lowest value would be of the cast shadow. The darkest area would be of the cast shadow. Okay, so this is how natural light works, and again, now we can see how and why the lines are parallel on the shadow of a natural light. Like whenever you're using the natural light, the kind of shadow you'll get would be um, parallel, the extreme sides. Okay. On the other hand, if you look at the same case with artificial lighting, this would be diverging. Let's talk about cylinders, something which has a continuous curved surface. Okay, cubes was easy because it has just different surfaces and which are flat, right? And they are just like not continuous. There are breaks in surfaces. There are one, two, three, four, five, and six surfaces which are being joined, right? There are breaks in surfaces, but when cylinders are in question, what happens here is it's just has a continuous surface here like this. In case of cylinders, what we do is, again, we'll have the same things here. There would be a light source, there would be a horizon here. Then the first thing that we'll do is we'll sketch the SVP, shadow vanishing point. This is the light source. Again, now we need to identify the light side and shadow side of this cylinder. For instance, when we looked at the cube, identifying the light side and shadow side was easy because there are surfaces. There's either one, two surfaces which have the light side, and other ones would be shadow side. Here we don't have divided surfaces, so we need to divide the surfaces. Okay. So now if you look at it from the top, the same cylinder would look like a circle from the top, from the plan, and this is the light source, right? So if this is the light source, this is how the light is reaching this cylinder, and this part of the cylinder is blocking the light. So this is creating the shadow, right? So now we can see that this point and this point are the 2 points responsible for. It takes a little time to show up there, but again, yes, these are the 2 points between which we have the shadow side on one side and the light side on the other side. Make sense? And this is the extreme part, like this one, like this is directly opposite to the light source. So this is the part which is exactly on the other side of the light, which would technically be the darkest area. So how do we find this? Okay, now we can see that this is passing through the center, right? The extreme point. So now here what we'll do is, if you look at the base here, look at the circle of the base, and if we mark the center here, okay. So now if we cross, like let the SVP and like project it through the center, we should get an idea of which is the extreme part which is opposite to the line. So this point that I marked right now is this, like say this is A, this is B, and this is C. So the point that I marked right now would be small b. Okay. And then if we draw a line perpendicular to this, and we have two intersection points on the base in the circle, and we have two lines here, these two lines should mark the division of the light side and shadow side. Okay, so this side here would be the shadow side, this would be the light side. Okay, this makes sense. Now we can actually name these points or nomenclate these points according to that. You can just name this one as capital A, capital B, and capital C. On the base, we'll have small a, small b, and small c. This is clear for everyone. Now we divided the whole thing into light side and shadow side. It didn't have any surfaces, it had a continuous surface, but now we divided that continuous surface into two parts. Okay, and now we also have an extreme side, like B is the part which is exactly opposite to the light. So now when we have divided this, again the same drill that we did with the cube. We had 3 points there, or 3 or 4 points between which we were trying to make the shadow. Here, the shadows formed between A, B, and C. Like, or from A to C, the continuous surface that we have, we are trying to make the shadow. Okay, B is just a division that we made so that it's easier for us, because the kind of shadow we'll get on the extreme would be a curve. Since the top part is a circle right now, so the shadow would also be curved, right? It would be a little distorted, it won't be a circle perfectly, but just to get an idea about that curve, we have used 3 points here. So
Mm-hmm.
to get a better idea about this curve, we are using this leverage point B. Okay, so now if we project that and we do the same thing here that we did with the cube, we'll just intersect the top points with these A and B and C, and the bottom points we'll just use from the SVP. We'll project it from A, B, and C, small a, small b, and small c. So this is one intersection point, second, and then we have the third intersection point. Okay, so now we have three intersection points, this one, and this one. Okay, these are the extreme sides, but now we'll just use these three intersection points and we'll try to form a curve between them like this. Okay, so now we have the line drawing for the cast shadow, and we also have the line drawing for the object. Here, what happens is this transition from darker to lighter areas, and a very smooth transition in that sense. So we'll have some highlight area here. The extreme highlight would obviously be on this part, like on the opposite part, somewhere here, where the light is hitting directly on the cylinder. Highlight is the part which is receiving the most amount of light in any kind of setup. For instance, if I show you this, again, I'm turning on the light for this. If you look at this object carefully, or let's use another object, a cylindrical object I have. Okay, I need to find a cylindrical object. But like, okay, for now, if you just look at this, there's one line. Can you see this, like white kind of line here? Like there's darker lines, but again, you can look at a white line here, right? Can you?
Mm-hmm.
Yeah. So the whitemost part or the lightest part in an object when you are like showing any kind of light on it is known as the highlight, and the darkest part would be known as core shadow. Okay, the darkest part that is there. So generally, the highlight would be like the extreme highlight or the main highlight would be on the light side where the light is directly hitting on that object. The core shadow area would be there on the opposite side, which is exactly opposite. If you look at it in terms of plan, this point would have the extreme highlight, and this part B here would be the core shadow area. Okay, but this won't be the case when we are trying to sketch an object here in isometric view, because there would be some reflected light, and these reflected light also cause some highlight. So we'll try to show the highlight on this side. Okay, we cannot see the extreme highlight here, but we'll have some secondary highlights here which would be responsible, which would be caused by the reflected light that is reaching the object. This would be the core shadow area, because this is exactly opposite to the light source, so we'll darken it as much as possible. This would be the darkest area here. And as we move towards the left, we'll reach the part A, which would have some highlight, right, because of the reflected light. So that would be a little light. So we'll just keep reducing the gradient here as we move from B towards the other side. Okay, so we'll just keep reducing this gradient here. This keeps getting less and less as we move towards A. Okay, so this is the kind of gradient change we'll have here. And beyond this core shadow area, if we move towards the right, again, this would keep reducing because this is the darkmost part. So anything left or right of it would be like having a decreasing gradient. So this is the kind of gradient we'll have on the right as well. But now this is all even. There will be some reflected light or secondary light, which would cause some highlights. So we'll just take care of that by just removing certain parts, for instance, like this. So this would show a highlight area here. It shows that some reflected light is causing this light area on this one. So now this is the kind of setup that we have. Now again, the shadow, the cast shadow that we are talking about works the same. So here you'll just have darker area right next to the object here. And as you move out, because of the reflected light, this keeps reducing. So this is the kind of setup. So this is the kind of shadow we'll have here. Yeah. So now in case of natural light, the same cylinder, I'll just tell you how that would work. Yeah, the same cylinder in case of natural light. Now, two things in natural light, right? We have the direction of light and we have the angle of light. Okay. So now we'll again, the direction of light, say that light is coming in, like this is the line on the base. So the light is coming in from this direction. Okay. This is the direction of light. So what we'll do is again, we'll mark the extreme points here. This one would be the extreme points opposite to the direction of light. Okay. And again, a perpendicular line here, which will give us the light side and shadow side. So now we have these 3 points, capital A, capital B, and capital C on the top, small a, small b, and small c on the bottom. Okay. So now what we'll do is we'll pass these like direction related lines from the base, again, parallel lines here, this one and this one. So these are the 3 lines here. Okay, I'll just project it a little more. This part is supposed to go out a little. And then the angle related light, like the angle related lines, the angle of light that we have. So from the top, you say this is the angle I'm fixing for the light. Okay, so this, and this. Okay, so now we have three intersections here, one, two, and three. And then this is the extreme, one extreme. This would be another extreme here, and you just join this in a curved fashion. This one. Again, the rest of the things work the same. This is the darkest area here, and on the left and right of this dark area, like the core shadow area, this terms, you don't need to remember these terms. You can just remember it like this is the darkest part. The part which is opposite to the light is the darkest part. So now if you keep reducing this towards the left and right, this is what you'll get. And on the right, this is what you'll get. Okay, then you can add in a few like secondary light highlights like this. So there's a highlight here, and then we'll have this cast shadow, again darker next to the object. As you move away, this will lighter. Now the thing to notice here is that if you look at the extreme lines, now they are parallel, unlike the artificial light. Yeah, if we sketch a cone like this, if we have a light source with this cone, cones tend to have a long shadow. I'll just make a small cone and I'll try to keep the shadow as small as possible. Say this is the light source and this is the horizon. Okay, so now we'll have an SVP here. Now it's very simple with cone. It's just a two-step process. Okay, you just pass the SVP with the center of the cone, center of the base of the cone. Okay, and then you pass the light source from the top and project it. You'll get an intersection. Okay, now you'll have a light side and shadow side here as well. Like this one would be the shadow side. You just join these 2 points to this intersection. That's all. And this is how you get the shadow. And the part which is right opposite, for instance, this one here, would have the darkest area, or this would be called as the core shadow area. Okay, as we move towards the left or right, this keeps reducing like this. On the right as well, this would reduce a little. And then we can have a few highlight areas here due to secondary light, because primary highlight would be on the opposite side that we can't see right now, but some secondary highlights can be there here. And now the kind of shadow we'll have, again darker towards the cone, like next to the cone, and as we move out, this will be light. So this is a sphere. So in 3D, if you want to sketch a sphere, if you're not using contour lines, in that case, a sphere just looks like a circle in 3D. Okay. So now we need to completely rely on light and shadow to show the overall profile of the sphere. So let's try to reduce the size of the sphere. Once we are done with that, we'll fix a light source. Say this is the light source. Now, if you imagine it like that, the kind of light which is being blocked by this sphere, okay, this is the light source, and it is there's a divergence or radiance from this light source. The light rays are radiant here. Now, the kind of light which is being blocked would be just a cone. If you look at these two rays, which are like on falling on the extreme part of this sphere, this is one ray and this is the other ray. This is basically a cone if you think of it in 3D. And this one cone is being blocked by this. So now always remember, this is known as the cone of light. In case of whenever we are trying to study a sphere, this is known as the cone of light, because there's just one cone essentially which is being blocked by the sphere. Okay, and this is responsible for creating the shadow. So here we'll just rely on the cone of light for creating the shadow. So in simple terms, for not going to a lot of technicalities, if you just draw a horizontal line here and you make an ellipse down here, so you'll get a fair idea about the kind of cast shadow you get. Okay, now this ellipse size keeps changing, like the horizontal axis increases, the vertical axis again changes in dimension depending on the kind of light we have, depending on the distance of the light we have from the ground. Okay, but this is the simplest way that I can tell you right now. Just make a horizontal line passing through this. Wherever this horizontal line is intersecting with the extremes of the cone of light, just make an ellipse between that. You'll get a fair idea about the shadow or the cast shadow. Now this size
Yes.
keeps increasing or decreasing depending on the angle of the light. You can have a bigger ellipse somewhat like this. Okay, you can also have a little more distorted ellipse somewhat like this, depending on the kind of shadow you have and depending on the angle of light that you have. Okay, or the distance of the light from the horizon. But again, this is more or less the most basic way of getting an idea about the cast shadow. Now, cast shadow aside, the most important part in case of a sphere, when we are trying to sketch a sphere, is the kind of shadows we have on the surface. Pay attention here, it's very simple, like it's just two things here. We'll just learn about three things here, okay? There are just three things that we need to take care of. The first thing is known as core shadow area, or it's also at times referred to, in just in case of sphere, it is referred to as shadow edge. Okay, so this part, wherever these two lines are touching the sphere, between this, if you just see this curved line here, like this line here, okay, if you just cut it in a cross section, you'll get a circle like this, right? So if you look at this side of the circle, it's known as the shadow edge or the core shadow area. So this would be the darkest area of the sphere. Okay, so this part is the darkest. So we'll darken it out as much as possible. So this is known as the core shadow area or the shadow edge. Okay. Then if you look at the center, like if you just pass a line through the center here, and if you just look at this bottom part, this is known as the midtone. So this would be a little lighter than this, but again, it would be darker than the rest of the sphere. So this part is known as the midtone. Okay, once you've made this, now the rest of the thing is that you just need to keep reducing the shadows, and then there would be a highlight where this light is directly falling on this sphere. So this part would have a highlight. Okay, so these are the three layers that you need to keep in mind. This is the highlight, this is the core shadow or the shadow edge, and this is known as the midtone. Okay, so now that we are done with these three parts, what we'll do next is we'll just keep reducing the shadow. Now, why these two parts are lighter? Again, the same reason that we had in cube. There are some reflected lights on the sides. So the light is reflecting and bouncing off these surfaces on the ground and reaching these parts. That's the reason why this part is light. Okay, so there's a lot of play going on here. The core shadow is the darkest because it's the part which is exactly on the other side of the light, because light is falling on this half. Okay, so this is the shadow side or the shadow face. Okay, and the other part is the sorry, the light face, and the bottommost part would be the shadow face. Yeah, and then we just transition this from darker to lighter on these parts. Even these parts are receiving reflected light, so they won't be extremely uh, light. Okay, so there would be some darkness here as well because it's more or less the shadow side only. So, but still some reflected light makes it look a little lighter. So that's the reason why we have these transitions here. This is the kind of transition we get to see on this part here. So now you get that mid-tone here, the core shadow area, and now as we move from this part towards the top, towards the highlight, we'll just keep reducing the gradient. Okay, like right from this core shadow area, we're just reducing the gradient here. Because it's a continuous surface, all of a sudden nothing can happen because it's a continuous surface. Even the shadow will
Mhm.
transition slowly. So we're just transitioning from this darkermost part here to the highlight area, which would be the lightest. As as far as the car shadow is concerned, here the part which is right next to the, again the same rule goes here. Okay, the part right next to this object, because it's directly being blocked by the sphere, this would be the darkest. As we move towards the extremes, this would keep getting lighter because of the reflected light. So that's the kind of shadow, a car shadow we have. We can erase the extremes. this is the kind of profile we have.